Hello, I'm Andrew Hallquist, and I am the build team lead on 5040. Our design process was introduced to us by a GE engineer at the beginning of our Velocity Vortex season, and ever since then we've been using it. Throughout the years, we've modified and used this practice to include equal participation and to create a judge-free environment. Due to recent events, we have also modified this process to be entirely digital using a website called Trello. Without further ado, here is our 7-step guide to success. As soon as the game is released, we get to work. We watch the release video and we read Game Manual 2 independently prior to our full team meeting. And then at the beginning of our meeting, we reread Game Manual 2 and we highlight the rules and scoring factors. These scoring factors are put onto sticky notes that are color-coded for their game phase. For example, red could be autonomous, green could be teleop, and yellow could be endgame. After this is done, we create a difficulty versus payout chart, where difficulty is on the y-axis and payout is on the x-axis. We define payout as point values, alliance efficiency, versatility, and repeatability. It's important to keep in mind how your robot will function with other robots and the variety of robots you will be allied with. We begin by identifying the task that is the most difficult and gives us the most payout. We use this task as a reference point for the other task that we graph. As a team, we decide where to plot each individual sticky note onto the graph, and from there we move on to phase 3.
Hello, my name is AJ and I am on the programming team for 5040. The step after creating your difficulty versus payout chart is prioritizing the tasks. A big advantage to this step is time management because you might not be able to get everything done on your robot you want to before the first competition. In order to prioritize, we use 3 categories: high, medium, and low priority. High priority is the most important tasks you want your robot to be able to do before the first competition. Medium priority tasks are ones you will try to get done if you have time before the first competition, but your robot will still do fine if they aren't completed. Low priority tasks are ones you aren't planning on getting done soon and may not get to throughout the whole season. Use your difficulty versus payout chart to help you decide where to prioritize tasks. Tasks that give a higher payout with less difficulty should be a higher priority. After prioritizing the tasks is brainstorming ideas. We create a category for each of the tasks that are in high and medium priority, and then we have all team members come up with as many ideas as possible for mechanisms that would complete each of these tasks and write them down on sticky notes. No idea is a bad idea. Then we go through each idea as the group and list the pros and cons of each idea and take a vote to determine which mechanisms to use. We do this for each of the tasks. With the current situation going on, there are several online alternatives your team can use. Trello is a great tool that acts as online sticky notes your whole team can access for free. Now you have the tasks your team decided were the most important for your robot to be able to do, and a mechanism your team thinks will best complete the task. Next, you need to put all of the mechanisms together. We draw out several robot designs that would have all of the mechanisms in it and make sure to consider measurements and sizes of the components to make sure the robot will fit in the size requirements. After drawing a robot, it is a good idea to CAD your robot. CAD stands for Computer Aided Design and essentially creates a 3D computer model of your robot. There are several free CAD programs available. Our team uses one called Fusion 360. This CAD model will be your fully designed robot. And now Nate will talk to you about the next step, which is prototyping.
Hi, I am Nate Matuzak. I'm the business team lead for 5040. I'm going to be walking you through the final parts of the design process. So you've generally drawn out how things are going to fit together on your robot and gotten the general idea of what your robot might look like if you were to use the parts you've chosen. But the most important part, probably, of this entire design process is to now prototype the parts that you've chosen to go with. Prototyping is a very important step because oftentimes things that look great on paper simply will not work in reality. It also allows you to refine your parts before you make your final robot component. You can use new ideas. You can refine the system before you actually start cutting metal or attaching bolts on the final product. So prototyping basically is using lower grade materials, even cardboard, scrap, just getting all that together to make proofs of concept. So if you were to look at those wheels on the right, those are wheels for a launcher, but it's not going to really launch anything in that form. It's just to prove the wheels work in their positions it's not meant to be reliable. It's not meant to be the final product. It's just meant to prove a concept. And there's our hanging hook on an Omni drive from Rover Ruckus. And again, it's just showing this hook can pull something up. It's not meant to be on the robot. It's not meant to be finished. That's all it's doing. The prototyping allows you to then go into phase 6, where you realize, hey, this idea didn't work. We need to go back to our other ideas for that component. So let's say you've settled on an idea for your cube placer, and your cube placer idea does not work after prototyping. You go back to your cube placer ideas, see what was our second option. You prototype the second option. And that's what prototyping allows you to do. It allows you to, if something doesn't work practically, even if it looks great on paper, it allows you to make sure that you'll still have something good on your final robot. It's always important to save every second choice, every third choice, every last choice during your design process, just in case you need to go back to it later. And there's definitely no shame in saying, we picked wrong, we need to go to a different choice. If you do that often and you are realistic about what you need on your robot, you'll have a much better robot. Then, of course, the final part of the design process is building the robot. This meme was made by an old team member, and it still holds true to this day. At a certain point, you need to realize you got to start putting stuff together, you got to finish making the mock-ups, and you need to start building your robot. What you want to do is you want to use all your lessons learned in prototyping while still sticking as close to your plans and combine those two into a functional robot. And this is going to be a long process, of course. You don't just build a robot in a day. But this will be sort of the culmination and the coming together of the previous lessons you've learned in the rest of the design process. What you always want to do is plan. So this is an example timeline for what we did on our design process one year. Day 1, reveal, begin our strategy. Day 2, move into our parts. Day 3, we decide on what parts we want to do. With prototyping, then we move on to prototyping. We take a week at least to prototype. Make sure that everything works out the way it should work. And then we don't actually get started on our robot's final parts until 2 weeks after reveal. It's always important to make sure that before you start cutting metal for your final robot, that you have a design that you are going to be capable of using and capable of succeeding with. Because once you've cut final metal, it's a lot harder to change out a mechanism than it is if you've just been messing around with cardboard prototypes. And the real question is, why in the world do we do this design process? And the thing is, it leads to a better robot for several reasons, because it forces you to realize this is what we need to do, this is what we need to focus on. Those individual chunks that we talked about, it lends itself to prioritizing one mechanism or one task in the game. And that leads to a specialized robot, which if you've chosen the task right, will do much better than a robot that can do everything poorly. It also divides the robots into workable pieces. It's a lot easier to schedule when you're saying, okay, we have a week to build the lifting mechanism, a week to build the drivetrain, than it is to say, all right, maybe 2 months to build the whole robot. The defined chunks of the different mechanisms allow you to create a more realistic schedule, allow you to assign work easily, and allow you to work on the robot in a sort of modular fashion, where you are often able to replace parts if they don't work. And, of course, the earlier brainstorming sessions of the design process lead to a situation where everyone on the team can contribute. A personal story from Team 5040 is, back a few years ago, the head of the build team, who was basically respected as the best builder on the team, had come up with an idea for a mechanism, and they were attempting to explain it. Nobody understood it. A first-year member misinterpreted their idea and drew a completely different idea on the board, but everyone liked that, and that became a robot idea, and we did extremely well with it. Just the creative variety of having every mind thinking is what leads to a successful robot, because you need to get ideas out there, or else you won't have any good ideas if you have no ideas. And if you guys have any questions, we would love to hear from you. Team 5040 is always open for an email. We have a YouTube channel which has a few of our older robots, for examples of what we've gotten out of this design process. And we would love to talk to you in the live roundtable. And good luck designing your robot this year.